As a little girl, I was roaming around in the forest in the spring, enjoying the fact that the snow had melted. I grew up in Norway. We have long winters, and looking for the spring flower was one of the favorite activities for kids back when I grew up. And looking for the Epatica nobilis, or liver leaf, was one of the most important things we did, because we got to get into the local newspaper if we were the first ones. We knew about specific places where the snow melted first, and we had some hints of leaves, etc., that indicated that this is the place where we could find this precious flower. My mother collected other types of data. She was making notes of when the lake froze over, and so she was making notes of that in her diaries. She also, of course, noted when the lake melted in the spring. She made that very carefully, handwritten, wrote down these observations. This is the first repository, the finding of the first spring flower and the metadata, data around these flowers. This is my first experience with collecting data, and was an important channel for me to get involved in what I do today. My name is Bente Lilja Bye, and I'm going to talk about data pipelines in digital twins. A simple representation of a digital twin is that you have a physical system and a virtual system. Data or observations of the physical system is used to create the virtual system. Now, the virtual system is running models, etc., and giving feedback into the physical system. And this way, we have a loop called a digital twin. What is a digital twin for biodiversity? It is defined as a sophisticated digital representation of ecosystems, species, and their interactions with the environment. This technology integrates various data sources to create a dynamic simulation that mirrors the real-world biological systems. The role of data in digital twins. Now, it is actually the core of a digital twin, is the very fact that we can create digital twin, is that we have so much data now. It's very varied. We have different sources. You saw the observations of the first spring flower, and we can make notes in books. That's one type of repository. It's one type of observation. But we also today have remote sensing, so satellites. We have various sensors networks. We have, for instance, for marine biology, we have vessels, we have drones and automated vehicles that we can collect data with. And also citizen science data. What type of data are we collecting? Environmental data, biological data, also ecosystems and genetic data, and the interactions between them. This is the kind of data that we collect. The challenge is, how can we put this together? The data obviously is very different in character. It comes in different formats, spatial and temporal resolutions. So for instance, when you are observing the spring flower, that's a very high resolution type of observation. When you are observing the Earth from a satellite, that's a low resolution observation. So all of this needs to be put together. That's the challenge. Another challenge is the amount of data, the variations of amount of data that goes into it. Can we rely on the source of data? Will it be sustained, the source of data, etc.? So these are the challenges related to data for digital twins. Now, we come to what is a data pipeline. So a data pipeline are systems that automate the movement and the transformation of data from source to destination. Here you see you have the data collection on the left side, data collection and acquisition, and at the other extreme end you have new knowledge and decisions can be made. In between, you have the data pipeline. What happens inside this pipeline? Well, you have to retrieve the data, you have to ingest the data into your system. As I said, the data is very different, so you have to harmonize the data, you have to make them possible to combine and then store them in your system in such a way that you, for the next step, can analyze it and process it using models, etc. And then finally, you need to present the result, visualization or tables or, on the format that the decision maker needs or the scientist with new knowledge needs. So this is basically a data pipeline. Now, the devil's in the detail. So we go further and we see step by step, what do you need to do to create this data pipeline? First of all, you have to identify the data sources. So when you're looking at your ecological system, the biology of your interest, you need to define what exactly will be describing what you're looking at the best. So you have to choose the data that you want to include in your data pipeline to create a digital twin. And you have to make some prioritization because, as we know, the world is very complicated, so we have to make some choices. So that's the first step. The second step is to ingest this data. So we want to make this flow of data as automatic as possible. And a way of doing that is to use so-called APIs that basically take data from one data storage and put it into another, your system in this case. And you need to do this automatically. That's ideal, and that's what you actually need to be able to use a digital twin. The next thing is that you need to store the data. So you have to find solutions. And data cloud storage is, of course, today quite familiar for many of us. But then you have databases, data spaces, and data lakes. They are different types of storage, and they are reflecting the need that you have to access the data. For some of the data can be sensitive, so you don't want to share it with everyone. In that case, data spaces can be a good solution. If you want to have very fast processing, you need to rip as much unnecessary information about your data away. So in that case, you are using data lakes. And the fourth step is then to do the data processing. In some cases, to prepare your data, to harmonize your data, you need actually to run some processes on your data to transform it from one format to another. That's something you need to do in the very beginning. That before then you put your data into a model or combine them so that you can understand more about the system that you are looking at. And finally, you have to visualize the data, and you have different dashboards. You can have interactive maps and present it in different actionable formats. So depending on the user of this data and the output, it can be presented, the same data can actually be presented in different ways. So this is very reliant on the end user in this case. So basically that's a step-by-step how you build a data pipeline. Now, let's look at a couple of examples of data pipelines in digital twins. You see like the standard setup. You have observations, you recognize this from the data pipeline, you have observations and collections of data, then you prepare your data in the data system, which consists of several of the steps in the data pipeline. You have then the analytic systems, and then you can actually play with your data. Since you have this data pipeline, you can play with it. You can pretend that what if this is happening with my ecosystem? What will happen then? That's one of the advantages of a digital twin. Now, when you have the pipeline that enables this what-if scenarios, if you like, you can then feed back what you learned into the system again and run the loop again. You see an example from mariculture. The digital twin is then enabling multiple perspectives that was not before possible. So this is a setup where you also include the environmental conditions around your mariculture. You are not only looking at one of the species, you are looking also at the species around. You are looking at DNA, and etc. And you can also include economic data, etc. And then you play with the system to see the consequences both on the environment around your mariculture, but also on the economic aspects of your mariculture. So this is one example. In the next two examples, you will recognize the structure of data pipelines. Each of the steps provides you with different tools to do what I just told you, that you need to prepare the data, you need to store the data somewhere, etc. So for each of these steps, there are tools that you can use. And this is an example of that. Here you see another example where we have put in some logos of the tools, of the platforms, of the cloud services that they are using. And this is how you can build your data pipeline in practice. So this is how it will be looking like, more or less. The future. Let's talk a little bit about the future of biodiversity data pipeline. There's a lot of emerging technologies. I'm sure you have heard about artificial intelligence. You have high-performing computing. You have Internet of Things that are continuously evolving, etc. These are tools that will be very useful also for biodiversity in the future. Another aspect is the interdisciplinary collaboration that is facilitated. So data pipelines enables industry, academia, and the public sector to more efficiently share data. So why should you do this? and how can you get started? By being a foundational component of a digital twin, a data pipeline represents a transformative approach to biodiversity conservation, offering enhanced monitoring capabilities, improved decision-making processes, predictive insights, and fostering collaboration among stakeholders. And these benefits are instrumental in addressing the pressing challenges facing global biodiversity today. So this is a very important why it's worth learning about data pipelines and to build digital twins for biodiversity. Here is a digital version of my beloved Epatica nobilis. To summarize it, first of all, you have learned about a digital twin, what a digital twin is. It's a replica of the real world, simply said. The role of data, that the variety and abundance of data is key to digital twins. You have learned about what a data pipeline is. You have learned what you can do step by step to build the data pipeline. I've shown you a few examples of how they can look like, and a few words also on the future of data pipelines. So what I recommend you to do is actually to start very simple. It's very overwhelming because the ecosystem, the biodiversity is very complex. I suggest that you start with a few data sets, play with them. So for instance, satellite data and some on-site observations of your favorite species, for instance. And then you set up a data pipeline where you can combine the data that you collected, put it on the storage, and clean the data and present it. A very simple step by step. And that's the way you can get started, and then you can move on from there.